Okay, so um, once you're satisfied with your smoothie profile, um, the next step then is to create your final design assembly, okay, in preparation for creating the final corridor. So I suppose the idea here is that once you've created your smoothie profile and you're happy with it, the final corridor that we create will just hang off of that, will hang off that profile, okay? So whatever level you've set that smooth profile at, that's the final level um, of your finished road surface. And because we're just hanging our assembly or corridor effectively off that smoother profile, we're just going to use the normal standard kind of lane sub-assemblies or one of those. Okay, so the assembly we're going to create, this is the finished article here. And I'm going to recreate this in a couple of minutes, but just to show you what it is first, very simple. It's an assembly with two layers to it. So we've got a 40mm wearing course over a 60mm binder course, and then you have a link here. I suppose for the side slopes of the regulation material, it's just the sloping down back down to the existing road surface at 1 and 1. Okay, so the reason and we've also, sorry, the reason that this extends out is the binder course here extends out 50mm wider than the wearing course above it. So that's how it will be constructed on site. And also this one slope is also how the regulation material will physically be constructed. So rather than just having vertical edges here on the sides, we've modelled this so that it accurately represents the real world situation as possible, so that when we do calculate our volumes, this should be pretty close to the real thing. Okay, so we'll remodel this assembly then, just to show how it's done. So click on, assembly here, create assembly. I'll just call this my final design 100mm overlay. Copy that. Okay, so I'll just put this in beside it. On the tool palettes then, go to the normal, or the lanes tab. Going to use the lane outside super layer varying width. So that varying width allows us to do this thing here with the binder course wider than the wearing course. Just going to add it on to one side first. Okay, when you zoom in, you'll see there's a number of layers to it. We want to set most of those to 0, the thickness of most of those to 0. So click on your sub-assembly. In your properties here, scroll down, set the default slope to -3. Pave 1 name is going to be wearing course. Depth is 0.04. Next one name is going to be binder course, that's 0.06. And then what we want to do is change this pave 2 width specification, change it to inside offset, outside offset. And if we just look at this in the background as we make this change, I want to change the pave 2 outside extender width to 0.05, so it pushes the whole lot out. Okay, and then I'm just going to make all of the other pavement layers within this assembly 0. Okay, so generally I found that entering 0 values into Civil 3D, it generally doesn't like them, but in this case it seems to be perfectly acceptable to put in 0 values. Okay, yeah, so that's them all done now. Okay, and then what we want to do after that is add a simple link assembly or sub-assembly that slopes from here at 101 down to back down to the existing surface. So I'm going to go to the generic tab in my tool palettes and use link slope to surface. In my properties here, it's going to set the slope to -100, which is 1 and 1, and click on that point, and that's what you get. Select both of those, click on mirror it to the other side, and that's our assembly, our final design assembly created. So in the next video then we're going to take that and create our final design corridor. Okay.